Now let's take a look at how to configure EIGRP in our lab environment and perform authentication between our routers. So to begin, let's take a look at our topology. Again, very similar topology to what we did with RIP. In fact, we're going to work with the existing configurations. We're not going to make any changes to the topology or anything along those lines. What we are going to do is begin by removing RIP. Let's go ahead and go to router 1. And on router 1, let's go ahead and remove RIP. Let's go ahead and go over to router 2 and remove RIP. And let's go to our ASA and do the same. Okay, now let's go back and take a look at the topology. What we're going to do is just enable EIGRP on router 1, router 2, and ASA 1. We're going to advertise all the networks that we have available to us. We're going to be in Autonomous System 100, so that needs to be common in our configuration on R1, R2, and ASA 1. Let's begin with router 1. On router 1, we'll give it the command router EIGRP 100, and then we need to give it our network statements. When we give it our network statements, we enter the network number. We know we have 198.52. Let's do a show IP interface brief just to verify that. So we have 198.51.100. So let's go ahead and do a network statement for that. And you'll notice we can do wildcard bits with EIGRP. So very similar to what we can do with OSPF. If we wanted to put in wildcard bits and then bring portions of the network in, we're able to do that. But what I'm going to do is just take this, make it a 0, and we're going to enter it as a classful network. We're going to do the same thing for 172.16, and then we're going to make sure that we do not do any auto summarization. So that's enabled EIGRP on router 1. Let's go ahead and do a debug. Let's go on over to router 2. Take a look at the interface, 172.16.10. Let's go ahead and enable EIGRP 100 for that. No auto summary. Now we can see that a neighbor established. Let's go back and look at R1. And we had a debug on, and we can see that debug gave us an output that we had a new peer. And then we saw the standard level 5 message that came up and said we had a neighbor change, and that neighbor is now up. So very simple. Let's go ahead and go back over to router 2. And let's bring in our other interfaces. Let's go ahead and add all the 10 networks. We'll drop out of there. Let's save our config here, and let's go over and look at router 1 now. Okay, so on router 1, I'll do a show IP EIGRP topology. Well, let's start with neighbor. Just take this slow. Okay, so we've got one neighbor on fast Ethernet 00. Let's go ahead and now take a look at our topology table. Show IP EIGRP topo. Okay, and there in our topology database, we can now see we've got all those 10 networks plus the 172.16 plus the 10.0 plus a 10.0.103 up there at the top. So it ordered them kind of funny, but if we were to look through them, we've got 101, 102, 103 up at the top, 104, 105, and then our 172.16. So those are all the routes or the prefixes that we expect to see. Let's take a look at our routing table. And in our routing table, there's that code of a D that tells us we've got EIGRP routes. Let's look again at the topology table. And in the topology table, we can see we've got our metric. So we have the advertised distance, which is for the 103 route, 128.256. Of course, we have our feasible distance, which is 156.160. So we understand what those values are. We also see that we have the letter P, which indicates that the route is passive, which is exactly what we want it to reflect. Okay, let's go over here to R2. Take a look at our EIGRP neighbors. There's router 1. Take a look at our topology. Same routes in our topology. Some of these are directly connected. That's just fine. Here's the 198, and we can see that that is via router 1. There's our advertised distance, and there's our feasible distance, 30720. That feasible distance, when I do a show IP route, is the metric value. And of course, we know that this 90 is the administrative distance, or that ranking of believability. Let's go to our ASA. Enable router EIGRP 100.
No auto summary.
Do network 172.16. Take a look at the addresses that we've got on this device, 192.168.45. We can even do passive interfaces. So we could say that the inside VLAN 45 is going to be passive. There's no reason for us to be sending updates on that interface. We can further reinforce that when we look at our topology. Note the ASA on VLAN 45, the only connection in there is to the PC. The PC is obviously not running EIGRP, so we can just go ahead and do a passive interface. We could do the same thing for R1 as well, and that would make for a more clean configuration. So if we came over here to R1, go into router EIGRP 100, passive interface F0/1. Now it'll listen, but it won't send, it won't neighbor up, all that good stuff. Okay, so let's go back over here to our ASA. Now we did see some messages over here. We had a neighbor change on router 2, and when I look at router 1, we also had a neighbor change there as well with 172.16.10.13. So we did neighbor up. Let's look on the ASA. Notice the difference. I'm not using the IP option in the command, so show EIGRP neighbors. Okay, so there's our two neighbors, router 1, router 2. And let's go ahead and do a show EIGRP topology. Same type of topology table that we saw on the router. So nothing, that should throw us off there. Do a show route. And there's our dual routes. There's our metric, 156.160 and 3720 for the 198 network. And now we have basic EIGRP routing in our network. Verify connectivity over to that server, 198.51.100.1, and we have connectivity. So that's basic connectivity. The next thing that we're going to want to do is enable EIGRP authentication.